Hi. The study of a heat engine is an important part of a mechanical engineering course. This video introduces the concept of heat engine, the term efficiency, and how this term is related to the first law of thermodynamics, second law of thermodynamics. At the end, you will be able to use this concept to evaluate a claim on a performance of an engine. The first law and second law of thermodynamics constrain the operation of a heat engine. The first law is an application of conservation of energy. Second law sets the limit on what is a maximum possible efficiency for an heat engine. Let us look at what is actually a heat engine. Heat engine is nothing but a device which converts heat energy into mechanical work. So it's a thermodynamic system, it's an energy conversion system. So the input to the heat engine is heat energy, output of a heat engine is the mechanical work. The work done per second is called as power. So an engine produces some mechanical power. There are different examples of heat engines: petrol engine, diesel engine, gas turbine, steam turbine. In all these kinds of engine, some form of fuel is burnt which produces some heat energy, and that heat energy is getting converted into mechanical work. So let us have a look at what is first law. First law of thermodynamics states that the work and heat are mutually transferable forms of energy. So we can convert the work into heat or heat into work. But it does not state what is the limitation of this conversion. For example, if I supply 100 kilojoules of heat to an engine, how much I can get as a work output? That is answered by the second law of thermodynamics. Let us have a look at the conceptual diagram of a heat engine. This is the heat engine which receives some amount of heat from a heat source which is at a higher temperature, and Qs is the heat supplied, and it converts part of the supplied heat into mechanical work, that's W, and the rest of the heat is lost to a heat sink which can be the atmosphere, surrounding atmosphere. So always the heat engine converts the part of the applied heat into mechanical work. According to second law of thermodynamics, heat engine must reject some quantity of heat while doing the conversion from heat to mechanical work. It is impossible to construct an engine which converts complete supplied heat into mechanical work. Let us have a look at what is efficiency. Efficiency is nothing but the output to the input. Output of an engine is mechanical work, that's W. Input to the engine is the Qs, heat supply. So efficiency is W over Qs. Now if we look at the energy balance of the system, the heat is coming into the system as Qs, and it goes out in two ways, one part as W, another part as Qs. So the W must be the work done, must be the difference between the heat supplied and the heat rejected. So if you substitute that value in this efficiency equation, efficiency is Qs minus Qr over Qs. Now what is the maximum possible efficiency? According to second law of thermodynamics, no engine can work with 100% efficiency. So what is the maximum possible efficiency? That is defined by the Carnot efficiency. The Carnot efficiency is Ts minus Tr over Ts. This is the maximum possible efficiency that can be achieved by an engine. It depends upon the maximum temperature or the temperature of the source and the temperature of the sink, which is the minimum temperature. So the Carnot efficiency is the maximum possible efficiency for an engine. Now let us have an activity. An engineer claims he has developed a heat engine which works with a maximum temperature of 500 Kelvin and a minimum temperature of 300 Kelvin and can achieve an efficiency of 50%. Check the claim is true or false. Now we know that according to second law of thermodynamics, the maximum possible efficiency is the Carnot efficiency. Let us calculate the Carnot efficiency of this engine. The Carnot efficiency Ts minus Tr over Ts, which is equal to 500 minus 300 over 500 equal to 0.4, which is equivalent to 40% efficiency. So the Carnot efficiency we calculated as 40%, but the engineer's claim is that the efficiency of this engine is 50%, which is more than Carnot efficiency, which is impossible to achieve. So this claim is false. Let us have a recap of what we have learned. A heat engine is a device which converts heat energy into mechanical work, and it works on the principle of first law of thermodynamics, which states heat and work are mutually transferable form of energy, and second law defines the maximum possible efficiency, which is nothing but Carnot efficiency. Thank you.